Today we're going to be talking about the midpoint formula and copying and bisecting segments. Our objectives for today, we will be able to find the midpoint of a segment in the coordinate plane. We'll be able to find an endpoint given a midpoint and the other endpoint of a segment. And we will be able to copy and bisect a segment using a compass and a straight edge. So let's start by talking about what congruent segments are. Congruent segments have the same length. And we can do this by using our compass. If we wanted to check this with a compass, we would put the center or the pointy end on one end and we're going to put the pencil end on the other. That'll show us how long it is. So that's how long EF is. If we take that and we don't change how far apart it is, if we just turn it, we can see that if we put the ends on GH, it's also the same length. So if EH is 3 centimeters, we now know, because the point and the pencil were the same distance away between E and F, as well as G and H, we know GH is also 3 centimeters. So if EF equals 3 centimeters and GH is 3 centimeters, therefore EF has to equal GH. And this is saying that their lengths are equal. Well, since their lengths are equal, we can make the conclusion that segment EF is congruent to segment GH. So this is saying the segments are congruent. We can also mark that they're congruent using hash marks. So if we put one hash mark on EF, we would also see one hash mark on GH, and that notates that they are the same length. Now, if we look at the segment AC, we have this point B in the middle. If AB is the same length as BC, I'm going to use 2 hash marks to show that they're the same, that means B is in the middle. So if AB is congruent to BC, we could then say that B is the midpoint. Of the segment AC. Which leads us to our next definitions, midpoint of a segment and a segment bisector. A midpoint of a segment is a point, see, midpoint, it is a point that divides the segment in 2 congruent pieces. So looking at our picture here, AB, if M is the midpoint, then we know that AM must be congruent to MB. A segment bisector can be a few more things. It could be a point, or a ray, or a line segment, or a plane that intersects at the midpoint. So if we have M being our midpoint, and we have the line M, and we'll make a point down here C to state our lane, we have the point, the line MC going through the segment AB at its midpoint. So we would say the line MC bisects the segment AB. So let's look at more at some midpoints. So find the midpoints between A and B on each number line. Label it as M on each number line. So if point A is here and point B is here, I would have to go 1, 2, 3, 4, 5, 6 spaces to get to it. So where would the midpoint or the middle be? The middle would be 3 spaces away at 1. So the midpoint between -2 and 4 would be 1. Let's look at it vertically. If A is at 9 and B is at 3, there's 1, 2, 3, 4, 5, 6 spaces again. So the midpoint or the middle would be 3 spaces away. 1, 2, 3. The middle would be at 6. How could we mathematically find the middle if we didn't have a picture? We could find the average. -2 plus 4, and then divide that by 2 to find the average. -2 plus 4 is 2. Over 2 would be 1. 1 was where our middle was. With our vertical example, we have 9 and 3. Divide by 2 to find the average. We'd have 12 over 2. The middle is at 6, just like we found on our picture. Now, what if we're looking for the middle, but we're not given the points horizontally or vertically? What if the points are diagonal from each other? So finding the midpoint on a coordinate plane. Find the midpoint of the segment with the endpoint C, which is at 6, 1, and D, which is at 2, 9. Now, currently, your graph paper does not have the X and Y axes drawn in on them. And that's because the paper we give you in class won't have the axes drawn in on them. We need to think about where these points are on our graph and figure out where the best place to put the axes are. Since we're dealing with all positive numbers and we know the midpoint has to be in between them, I'm going to put my y-axis here and my x-axis down here because we know we're not going to need any of the negative numbers. So I'm going to start off by graphing C, which is at 6, 1. And I'm going to label it point C. Then I'm going to label point D at 2, 9. And we want to know where the middle of them is. But they're connected, if we connected them directly, that's a diagonal, and we can't quite see where the middle is. So what we have to do is look at it vertically and find halfway, and horizontally and find halfway. So if we're moving vertically, to get from D to C, we'd have to go 1, 2, 3, 4, 5, 6, 7, 8 spaces. So for our midpoint, we would only go down 4. Then we can do the same thing horizontally. To get from where D is to C, we'd have to go 1, 2, 3, 4 spaces. So halfway, we'd only want to go 2 spaces. So basically, from D to halfway would be down 4 and over 2. That would be my midpoint. Well, what's the coordinate of this midpoint? That point is at the point 1, 2, 3, 4, 1, 2, 3, 4, 5. So our midpoint is the coordinate 4, 5. Now, we were given coordinates that are fairly close together and don't take up a lot of room on our graph paper. But what if they were? What if we were given bigger numbers? A shortcut would be the midpoint formula. The midpoint formula deals with the averages of x and y. So if C is my first point, I'm going to label it as x1 and y1. And then my D can be my second point, so it'll be x2 and y2. So for our coordinate, because we know our final answer is going to be a point, so we're going to set it up as a coordinate. My x's will get averaged, so we're going to add them together and divide by 2. And then our y's will get averaged, so we'll add those together and divide by 2. And when we simplify each of these little formulas, we'll be left with the coordinate of our midpoint. So let's practice with this problem. 6 was x1 plus 2 is our x2 over 2. 6 plus 2 is 8 over 2. And 8 over 2 is 4. So far, so good. Our midpoint on our graph, the x value is 4, and doing it with the formula, we got a 4. Let's try the y's. y1 was 1, plus y2, which is 9, over 2. 1 plus 9 is 10 over 2, which simplifies to 5. And look, we got the same thing as we did graphically. Now, what if we were given the midpoint and one end? How could we find the other end? We would know that 4, 2 is our midpoint. So that would have to equal x1 plus x2 over 2 and y1 plus y2 over 2. Now, since we have one of the endpoints, we know x1 and we know y1. So I'm going to go ahead and fill those in to my formula. Now make sure to take notice. The little 2's with the x and the y, those are subscripts letting us know which coordinate they're coming from. It's not a squared or a times 2. It's just a part of the notation with the variable. So 4 is my x coordinate, and I'm going to pair that up with the x part of my formula. So I know that 4 has to equal 0 plus x2 over 2. And then 2 goes with the y part of my formula because 2 was the y coordinate in the midpoint. So now let's solve this. To undo our dividing by 2, we're going to multiply by 2 on both sides. And I get that 8 equals 0 plus x squared. Subtract 0 from both sides. My x2 coordinate would have to be 8. With y2, again, we're going to multiply by 2 to undo the division. I get 4 equals 1 plus y2. Subtract the 1 from both sides. My y2 coordinate has to be at 3. So therefore, the point K is at 8, 3. Now, how did I know that it was going to be K? Because we're looking at the segment JK. I was already given J, so we must be looking for K. Could we do this graphically? Indeed, we could. Now again, we're dealing with positive coordinates, and if this is one end and this is the other, these numbers are bigger than the endpoint numbers, so I know I'm going to stay in the positive part of my graph again. So 0, 1 is my endpoint J, and then my midpoint is at 4, 2. How do I get from J to M? Well, I have to go over 4 boxes and up 1. So to get to the next coordinate, I'm going to go over 4 boxes and up 1. That must be where K is. Is that the same coordinate that we came up with by solving? 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. All right, let's move on to some constructions. Constructions. We're going to be using 2 tools to help us with constructions. We're going to be using a compass and a straight edge. And a straight edge is literally what it sounds like. It is anything with a straight edge. So a lot of times we're going to be using rulers just because they're straight. We're not actually going to use them to take measurements. So to copy a segment, we're going to use a compass as a ruler like we did to check the size of the segments at the beginning. So like I did earlier, I'm going to take the pointy end, the middle of my compass, and put it on one of the endpoints of my segment. I'm then going to adjust the size of my compass to put the pencil on the other end. So before we can start drawing our copied segment, we need to draw a point. I'm going to draw the point over here, and I'm going to make it point W. So the first step, draw a point. Then we'll set up our compass to measure the length of our segment. So measure the segment using the compass. I'm now going to move this, and I'm going to take my middle pointy part and put it on the point that I drew. I'll then take my pencil and draw an arc. Now, my fourth and final step will be to connect the point to the arc using a straight edge. So I'm going to use my ruler. I'm going to set it up on point W. I'm going to draw a straight line, maybe. And I can have it at any angle I would like, as long as it connects the point to my arc. I just draw straight along. And there's my segment. If I put a point on this end, let's make it X. I can now say that segment XY is congruent to segment WX. Our last thing today is going to be to bisect a segment. So these are our steps of how to bisect a segment. Remember, that means to cut it in half. So we're going to start off with a given segment. You're then going to put the center of the compass on the endpoint, either one, and open the compass more than halfway. Then we're going to draw arcs above and below the segment. So I'm going to put my center on one end. I'm going to bring my compass in a little bit more than halfway. And then I'm going to draw an arc. You can either just draw you can draw an arc above and below, or you can just go around and make one big arc that passes through the top and to the bottom. Then you're going to keep the compass the same width. And put the center of the compass, on the other endpoint. And then again, you're going to draw an arc that goes from the top to the bottom, or the bottom to the top. And you want to make sure you pass through so that they both intersect like it does right there. So when you draw them, make sure they intersect the first ones, like you see with A and B there. Our final step is to connect the intersections of the arcs using a straight edge. So if I take my ruler and line it up with A and B and connect them, it'll go straight through the center of the line. What do we also know from this box, or by putting the corner of the ruler at the intersection? This is not only a bisector, but it's also a perpendicular line. So this could be called bisecting a segment, or it's also known as a perpendicular bisector. Now, in your summaries, go ahead and describe how midpoint and segment bisector are similar and how they're different. Also, can you describe a real-life situation when you may need to find a midpoint? That's all. See you in class.